gentlemen, Dobardan. My name is Murat Cakan. The first name is my student, my Master of Science student, who is not here, who is not present. I'm gonna try to present you this investigation as much as I can. I have to say that it's a very moderate and modest research activity. The name is Investigation of the Effects of Night Cooling on Building Thermal Performance with HAP, Hourly Analysis Program. The layout of the presentation is as follows. I will introduce the problem first, and then I will briefly summarize you, or make a summary for you, the fundamental concepts of night cooling. I will then introduce the methodology, and I will try to finalize my presentation with the results and the conclusion part. Well, everything has a reason. The reason for this, or behind this investigation, was a competition. Maybe you know, in 2002, Department of Energy, US Department of Energy, started a competition named Solar Decathlon. And in 2019, the first Solar Decathlon was organized in Morocco, in Benguerir, the solar town of Morocco, Benguerir. 18 university teams, or consortiums better, because teams were composed of different universities from different countries. 18 teams were eligible to compete in the competition, and one of these teams was my team, Team Bosphorus from Istanbul. We were a consortium of two universities, Istanbul Technical University and Yıldız Technical University, two rather prestigious universities in Istanbul. So the picture on the photograph on the left shows us the 1/3 of the competition team, Team Bosphorus, at an event organized prior to the competition, and the two pictures up and down on the right hand side are actually movies. I'm afraid, yeah, it's not working, sorry. So let me, there's always something wrong with these things, I'm sorry. So anyhow, what I was going to show you is the sequential video of the construction or erection of each of these 18 houses. By the way, I told you about the Solar Decathlon competition for those of you who don't know the competition, but actually competition is there in order to disseminate knowledge, academic knowledge, but also societal knowledge on building residential units, which are sustainable, energy efficient, and affordable. And affordability was actually one of the most important pillars in the African competition. So the erected buildings, or the presented buildings, was asked to be affordable as much as possible, because we were going to serve it for the African users. So, Team Bosphorus, after a very difficult duration of 2 to 3 weeks, we were able to come up with this Riyard house. The name Riyard refers to two things. Riyard, thinking the yard, the inner yard again, and Riyard because it is the name of a typical traditional Moroccan house typology. So the name of the typology, the traditional Moroccan typology, was Riyad, but we somehow distorted the word and made it Riyard, rethinking of the inner yard. Why inner yard? Because we immediately saw that in Morocco, inner yards are important milieu to gather, to cook, to chat, to spend evenings in rather warm, hot nights. And we find some similarities with our country, Turkey, because in the southeastern border of Turkey, Syrian border especially, there are towns where these type of buildings topologies exist. So we said, well, it could be a good idea to investigate and to build such a residential unit. And this was the outcome. I will show you 2 or 3 more pictures. This was the, I'm sorry about the quality of the reflected image on the wall, but if you come close, you will be able to see a nice and beautiful and quite comfortable living room, a nice entrance to the house, and a quite cozy inner yard with traditional divans and some flowers. But these are all makeup. I mean, this is the outside. What was the important issue in this house was the fact that it was built out of soil panels. Soil panels in and out. And in between those 2 solar panels, we put some local material, reed, whatever we can find, whatever is available. In Morocco it was reed. Perhaps in Turkey it would be something else. Even scrap paper could be the material. But we sandwiched this material, this reed material if you wish, in between 2 solar panels, which is 7 centimeters thick on both sides. And by this way we were able to bring down the U value to 0.1. Why is that? Because Bengerir is dry, Bengerir is hot. In some seasons, in some months, Bengerir temperature swing was quite dramatical. 40 degrees during the day, let's say, to 15 degrees in the evening, or 20 degrees in the evening. So, I will show you, we worked on many different innovative approaches, but I will show you only 3 of them. One of them was the wind catcher. Well, the wind catcher, as you see it from those 2 pictures, it was able to capture the wind coming from the prominent direction of north, because 250 days out of a year, the wind was blowing from northern directions. So we placed our house such that the opening was towards the north direction. And we simply make an inclination, or give an inclination to the PV panel facade of the house. This way we were able to bring in the fresh and cooler air into the inner yard. The second innovation was about the heat pump. The outer unit, or the condenser of the heat pump, the environment of this heat pump, the temperature of this environment was brought down to a lower temperature value by the introduction of an evaporative cooling system. This was the second innovation. And the third innovation was night cooling. Night cooling, because we saw already, as I said before, we saw that the temperature swing, a daily temperature swing, was quite dramatic, especially at certain times of the year. Well, at the end of the competition, well, first I have to say that it's a solar decathlon. So there were a total number of 10 competitions. 6 of these were juried, and 4 of these were measurements. So we were lucky enough to get the first prize, 3 first prizes out of these 6 juried competitions. So we found ourselves very lucky and confident in that respect. What was our first prize titles? It was first engineering and construction, then innovation, and finally communication and social awareness. Unfortunately, we were not one of the first third consortiums, because we lost a lot of points in the measurement campaign. We were not able to create power with our PV panels due to different reasons, but anyhow. But still we consider ourselves very lucky, because in terms of engineering, innovation and communication, we became the first. Okay. Now, about the introduction to night cooling. We all know about the night cooling, the benefits of the night cooling. The night cooling, by the introduction of night cooling, one can absorb the external loads, external heat loads, and internal heat loads, the plug and process loads, if you wish, easily. But, of course, you have to make good decisions, otherwise it can turn out to be a nightmare doing night cooling. Sorry. Why is that? Okay. Solar and internal heat loads are maximum at daytime. This is why night cooling is utilized. The lowest temperatures occur during nighttime at seasons where cooling is required. For this reason, night cooling is an indispensable method that's used to take away the daytime heat accumulation. Night cooling may be effectuated by natural means or by forced convection, or in other words, by fan. Natural ventilation systems, including night cooling, employ either thermosiphon or wind pressure effects to apply their impact. But we have to be careful. Night cooling performance also depends on the climatic conditions. Best performance of night cooling can be obtained in dry and hot regions and continental climates, where the difference between night and daytime average temperature is significant. There's another issue. For an effective night cooling, the relative humidity of the air must be as low as possible in order not to cause condensation in the interior surfaces. For a comfortable thermal environment, a room temperature range of 21 to 27 degrees Celsius must be maintained at the end of the night cooling application. When we come to the methodology, we used a dynamic energy analysis program called hourly analysis program developed by Carrier. We used measured weather data for all 8,760 hours of the year to calculate building heat transfer and loads, air system operation and plant equipment operation. The unit we designed and built was about 100 square meters. It was an earthen house, as I said before. And out of curiosity, we decided to test this house, or numerically test this house, in 3 Turkish cities, namely Ankara, Istanbul, and Izmir, along with Bengerir, the Moroccan town. As a parametric, since we were doing a parametric study, we changed, or we used 3 air changes per hour, namely 3, 5, and 8 air changes per hour, and to compare those performances, we also tried the no night cooling case as well. Climate data of Bengerir came from 1-year data of 2017, unfortunately, whereas Ankara, Istanbul, Izmir was made available by HAP program. I think it was an accumulation of 20 or 30 years of data. Here, these 2 pictures show the geographical positions of the 4 cities. You might be familiar with the Turkish cities, especially Istanbul, the geographical positioning. But, you know, about 6 months ago, I didn't know the location of Bengerir. It's here somewhere. So It's just a little bit south or southeast of Marrakesh. It's quite far away from Atlantic Ocean and quite far away from the Mediterranean Sea. So it's a continental climate, but a continental climate in the sense that there's no snow, of course, but the wintertime temperatures are quite low, maybe quite low. Okay, I'm coming to the end of my my presentation. I will just show you the results in 4 or 5 slides, and that's it. That will be it. This slide shows us the daily temperature variation in 4 cities. Starting from left, Ben Gerir, and then Izmir, an Aegean city, so western Turkey, then Istanbul, and finally Ankara, the capital, which is Inner Anatolia. Underneath the names, underneath the names exist the latitudes, and just beneath the latitudes you can see the climatic regions that these cities belong to. We see that the temperature swing, the daily temperature swing in Ben Gerir is quite drastic, but it's not the only, it's not the swing which counts, but also absolute temperatures are quite high. In Izmir, the swing becomes a little bit more moderate. In Istanbul, very smooth, no swing at all. And in Ankara, we see again a drastic swing, but with the exception from Ben Gerir that the temperatures, the absolute temperatures, are lower. Now, this is a qualitative picture of a 6 months variation of day start temperatures in Ben Gerir. The upper line, upper curve, the blue curve, if you can see the color there, is no night cooling curve. So, if you do no night cooling in Ben Gerir, the average day start temperature is around 27 to 28 centigrade degree. It's quite a lot. But trying ACH of 3, then 5, and then eventually 8, we will be able to bring down the day start temperatures down to 23.5 centigrade degree. What does it mean in practice? This means that we don't have to start our air conditioning devices immediately as soon as we wake up early in the morning. Okay? This is the benefit, the most important benefit. We did the same kind of analysis for Izmir from May to October, I repeat. In Izmir, it seems like the set temperature of 24 degrees Celsius as a day start temperature may not be reached for the 80% of the cases, except in October, the 6th month. So it may not be very interesting to use night cooling in Izmir. We deduced this conclusion. For Istanbul, not much change is there than Izmir. But for Ankara, there are good news. In Ankara, almost as soon as you start doing night cooling, you go below 24 centigrade degree, which is the set temperature we used in this analysis. 3 more slides. Now, what I showed you in the last 4 slides was qualitative, but this one is addressing the cooling load in terms of kilowatt hours. The first blue line shows values around 500 kilowatt hour per 6 months. But introduction of the night cooling would decrease these amounts to an important amount, down to 300 kilowatt hours for Ben Gerir. The same thing is also valid for the 3 Turkish cities, but the most striking one is Ankara, out of these three cities. My last slide, conclusions. Among the four cities, Ankara benefits the most from night cooling. Bengirir's and Istanbul's benefits are comparable. Izmir performs the worst. Being the most humid city among all, Izmir must be careful in employing night cooling due to condensation risk. 6 months average of cooling load reduction reaches an average of 40–45% for Ankara, whereas this reduction stays at an average of 23–24 for Bengirir. Having the highest cooling energy cost, Bengirir benefits from night cooling in terms of energy cost, because the temperatures are so high that although it has a quite modest reduction in cooling load, in terms of cost, it has the highest reduction. And finally, to reduce further the energy cost reduction in Bengirir, one can think of using a higher thermal mass building, because the thicker the building walls, the more heat can be absorbed by night cooling. With this, I complete my presentation. Thank you for your attention.